In this video, we are going to discuss the concept of seasonality. Seasonality is very important because it represents the repetitive frequent events we might find in any time series. And we will see that we will actually find it in most time series we will study in this course. Seasonality tends to be relatively easy to identify in time series because it results in repetitive peaks and valleys. Between each of those peaks and valleys, there will be a relatively fixed duration. The width of the peaks and the valley might vary from a time series to the next. Similar peaks and valleys should have a similar magnitude and similar width. Turning to the time series data we have at the bottom, the US retail sales data, we can see again that the sales tend to spike every December and then they tend to crash every January and February. Now, again, that occurs at a relatively fixed frequency, about 1 year. If we look at those peaks and valleys, we can note that every December it increases by a similar amount and it lasts only for 1 month, and every January it crashes and it lasts for 2 months. I want to make the very important point that seasonality has nothing to do with seasons. It's just a repetitive pattern in the data. To show that, I have some data here with the internet browsing behavior for roughly 1 million users, tracked for the period between Thanksgiving and the weekend before Christmas. Now, on the y-axis, we have the total file size, which is a rough measure of how many web pages they've browsed. And on the x-axis, we have the date. We can see a clear seasonal pattern here, that is that people browse the internet Monday through Friday, generally while they are at work. Then it drops on the weekend. So this seasonal pattern repeats weekly. We could get even more interesting seasonal patterns by looking at the hourly usage. We would see that people browse the internet during the morning work hours, take a break for lunch, and then resume browsing during the afternoon. They are basically doing their holiday shopping while they are at work. A sure way to identify seasonality is to look at patterns in the residual. That means that you have removed some other time series component, especially the trend. So sometimes you can see seasonal patterns directly in the original data because it's relatively clear, like here in the US aggregates retail sales data. However, sometimes when you have more noise or when you have cycles, it might be more difficult to identify. So in that case, you will remove the trend first and the cycles and then look at the residuals to see seasonal patterns. So here for our retail sales data, we can see that once we have removed the trend, on the right, the residuals which capture the variation that remains show clear seasonal patterns. We have spikes every December, and we have drops in January and in February every year. So how to build in seasonality in our model with the trend? Well, it's relatively easy. We can create indicator variables that indicate whether we are in a specific seasonal period or not. So in our case, we already have the trend in our model. The trend is T, and it's the number of periods since the first observation. Each period here is represented by a month. Then we add the I variables, the indicators, and we might have K indicators. They will be equal to 1 if we are in the specific seasonal period. So for instance, if we are on weekend and we are working with weekly data, the I variable will be 1 if we are either Saturday or Sunday. And then we have all the coefficients associated with these indicators. So here it's beta hat 2 to beta hat k plus 1 if we have k indicators. And they are interpreted as the expected deviation from the general trend associated with that period. So we have the general trend, which is captured by beta hat 1 in front of the t, which is the variable that represents the trend. And then the other betas here are the deviations from that trend. So we have seen that we can account for seasonality by using dummy variables or indicator variables. This could be only meaningful if we have multiple repetitions in the data. So if the seasonality comes every year, we need to have many years in the dataset. You can either create a full set of dummies, so for all the month, for instance, except one, which would be the reference group, or only create dummy variables for the month that indicate seasonal spikes. Remember that you need at least one reference group, so one group without an indicator. If we create indicators only for the month with spike, then the reference group will be the average for all the other months that are not represented by any specific indicator. So for the retail sales data, I created 4 indicator variables: December, January, February, and March. Then I ran the regression with these indicator variables and the date, which is for the trend, so the t variable in the model we've seen before. And we can see that we have these regression results, and that the coefficients for December, January, and February are quite large and very significant, with a p-value that is smaller than 0.01. And the December coefficient is 51,000. Remember, the unit is millions of dollars. And the January and February are well below, because they are at minus 32,000 of millions and minus 35,000. For March, however, you can see that we have a very small deviation, minus 97, and it's not significant at all because the p-value is 0.97. So it means that for March, we don't have a significant deviation. We don't have a deviation far enough from the trend to separate it from the reference group, which are the months that we have between April and November. So looking at the predictions for the model, we can see that now we capture both the trend and some seasonal variation. So we have peaks at the right spots every December, and we have crashes at the right spots also every January and February. The magnitude of the peak seems to roughly match what we find in the data. We still have some observation where we have larger peaks in the data than we predict with our model. But overall, it's performing a lot better than just with the trend.